Mic test.
Test, test. Cool.
The music is on.
All right.
Give me a little bit more.
Yep. Test, test. Wow, I can hear myself.
Yeah. I'll turn you down and adjust once we get the music.
Yeah, totally.
But yeah, you can click off for me right now. You keep it off. Give me audio check.
No, it's fine. Testing. Hello, hello. We're going to get started in just a couple of minutes. If y'all could take your seats, we'll get started with the first talk.
Check. Can you hear it? Yeah.
Testing. Seems to be working.
Swiz, are you in here? Can you do a mic test? Wow, that was the fastest y'all have quieted down in some time. It's almost like a pandemic I just entered back into. How is everyone doing tonight? Are we happy to be back in person? This is our second meetup in not 60 days since the last meetup 2 years ago. So I'm really excited to be back again in person again for our second in-person meetup post-pandemic. So who am I? My name is Benjamin Dunphy. I work for a company called Real World React. And what Real World React does is we do events like this. If this will work, if the slider will work. I will go back to the computer. Yeah, so we do events like this. We do meetups, we do conferences, and we do consulting. We do workshops. So we've trained engineers all around the country, not the world yet. US is pretty big, on any type of technologies, React, Redux, RxJS, GraphQL, etc. And one thing I skipped over, this is when you're out of practice. Tonight we have 3 amazing speakers, including Fernando De La Madrid from Checker, our gracious host tonight, who's going to be covering server state handling with React Query and hooks. And this is coming from a Redux fan. We will also have Colin McDonnell. I didn't have yours in the notes here. Who's talking about end-to-end type safety, right? The holy grail of end-to-end type safety, which I'm really looking forward to. And then we did have Swiz Teller, who was going to interview Rick Takes, who is a senior director of engineering at Netlify. Unfortunately, Rick got the COVID, so he graciously did not come. So we're going to be interviewing him at our next meetup next month. But in its stead, I will actually be interviewing Swiz, who is a senior engineer and actually wrote a book called Senior Engineering Mindset. So he has a lot of good insights into that. Let's see if this is working. Hey, it's working. So that's a little bit about Real World React. We also run conferences, including Reactathon. Does anyone stir up hands? Who's heard of Reactathon? All right, about 10%. Interesting for this crowd. Reactathon has been around since 2016, 2017. And we came back again in person this past May. We took it outdoors at this beautiful venue in Orindo, which is just across the Caldecott Tunnel, called the Cal Shakes Amphitheater. It was just absolutely stunning. Not gonna go through too many photos here, but it was a great time. Like 400 people showed up, some incredible speakers. And you can see all of the talks on a YouTube channel at youtube.com/realworldreact. We have some really interesting talks there, including one that has gone pretty semi-viral. How many of you use UseEffect? Show of hands. Should see every hand go up. Those who are not, maybe you're a Vue engineer. This talk is called Goodbye UseEffect, and it's from former Microsoft engineer, now Stately founder, David Korshid. That one's getting over 200,000 views, so I'd encourage you to go check that out. Some interesting opinions there. Some other speakers, including Ryan Florence from React Writer, and many others. And if you watch those talks, you'll probably see this animation at the start of it. That's Event Loop Productions. Event Loop Productions is another company I founded that is a production company. We're an event production company, and we also do DevRel as a service. So we can help your company to run events, to run meetups, to engage the community with developer relations. And that's it about Event Loop. And I'm also excited because one of our early clients, Netlify, we helped them to build jams.conf. We did the first 4 jams.confs for them, and then they took it online because of the thing that happened. And I'm really excited to bring it back this year. It's coming back on November 7th to 8th, right here in San Francisco. We're calling it the biggest party of the year. So this is a conference that celebrates developers like you. And they graciously provided a number of t-shirts for us that you can get over there, along with some stickers. And if you'd like, you can get 20% off the ticket with code REACTSF. If you need any more of a discount, just message me and I might be able to help you out, or just come chat with me. So you can learn more about that at jamstack.org/conf or jamstackconf.com. And once again, use that promo code REACTSF. Okay, so that's the end of the announcements. Tonight we have Checker to thank for hosting us. And I'm really excited to invite a senior engineering manager from Checker just to say a few words about his company. So please join me in welcoming and thanking Checker and senior engineering manager, Jeremy Ho.
Thank you. Thank you very much. What are we here? What do we do here? We are a technology company. We're a software company. Checker is a software company whose domain is background checks. Now, I don't know if you all are sort of very familiar with the background check process, but it can be, for some people, like me in my past, I was lucky enough to think of just background checks as just like, oh, it's just a step. But for some people, background checks is an extremely scary thing. Background checks can be used against people and to deny people employment in many cases. And so, I mean, you imagine in the world of hiring, you have your hiring funnel and everybody, you get down to the certain set of people that you want. And then all of a sudden background checks comes in and says, no, can't hire that person. No, can't hire that person. So anyway, at Checker, part of our mission is, our stated mission is to build a fairer future. And we try to make it so that background checks maybe aren't as bad a thing, and that we can reduce some bias and we can enable people to get employed. When I started at Checker, our goal was like, we're going to unblock 100,000 people from getting jobs. And we managed to meet that goal. But now we're at the point where we're like, hey, our goal is 4 million this year, and so I feel very proud. I feel very happy that, to be a part of that. Now, we got a bunch of Checker engineers. Will you guys wave your hands around here? If you are interested in fair chance hiring, come talk to us. I know there's a whole cohort of folks here tonight for whom fair chance hiring is near and dear to their hearts, and it really, like, I don't know, I've had a great experience and learning about it, and I encourage you to explore it, and through us, in fact. Anyway, thank you. That's nothing technical. It's just like what we do,
Let's give it up for Jeremy and Checker. Thank you. We obviously can't come back in person without hosts like Checker, so we really do appreciate them. And they also provided the food. Couple of housekeeping items. If you need to use the restroom, go out these doors, go down the hallway and to your left, and then it'll be on your right. It is a genderless bathroom, so there's one door and enclosed stalls for everyone. I would call out, just be careful with the soap. It wants to shoot you in the chest when you squirt it. So do a little shimmy. Okay, I'd like to invite our first speaker up to get set up. This is always the awkward part. While I intro him with the notes I don't have. I'm really excited for this first speaker. His team reached out to me a few weeks back saying they want to give a talk. And when he told me what the talk was about, it seemed like, well, we got this kind of theme going. We had end-to-end reactivity last month, and now we got end-to-end type safety. So I'm really excited about this. So he's a senior software engineer at EdgeDB. Please join me in welcoming Colin McDonnell.
Thank you, Ben. And thank you to Checker for having us and providing the amazing food and the amazing views. I don't know if anyone has been to the bathroom. The bathroom has a window with the best view I've ever seen in my life. So I'm Colin. I'm going to talk about end-to-end type safety, which is I guess a problem or a design space, I guess, that's near and dear to my heart. I'm also head of developer relations at EdgeDB, which I think is doing some very cool things in letting you actually write queries and pull data out of your database in a way that's fully type safe. And that's ultimately the source of true type safety in your application is your database. And so we're going to kind of talk a little bit about what end-to-end type safety is, because people mean a wide range of things when they say that term, and then kind of talk about the modern set of approaches that seem to be solidifying right now. And then again, talk about the kind of sources of type safety and why some tooling around that, the tooling around that is ultimately going to be increasingly important when end-to-end type safety is more and more of a best practice, even more than it already is, which I would say it kind of already is. So a bit about why I'm interested in this problem. I started a company in 2019 building medical record software. And I was a few years into my career at that point, but not nearly good enough at TypeScript to actually make good decisions about the tech stack at that time. And so basically what I decided to use for my actual database backend was Neo4j, which is a graph database that if you go to their website, it explicitly says it's not really intended for application development. It's more like pull in your like totally amorphous blobs of data and run analytics on them with our query language cipher. And it is a graph database, so everything is stored just as nodes and edges. If you haven't used one before, basically both nodes and the links between them can have properties on them. And you can also assign one or more labels to each of those as well. But there's no real schema. You can have a property on one node that's name string, and then another node, you can just assign a number to that, that same property name. And so that there's no real enforcement, there's no real type safety it's providing for you. And it can feel sometimes instead of, a nice crystalline set of nodes and edges, like your database is just a big bowl of spaghetti and you're fighting to actually get it to give you any real sense of safety, or it doesn't really help you sleep at night, I suppose. So what I did as a solution to that is start looking for ways to get type safety at the application level. So if your database is going to do it for you, then what I ended up doing is working on a TypeScript library called Zod that is TypeScript schema validation library. And I used this ultimately to validate every object that I was writing into my totally schemaless graph database to make sure that it conformed to the type that I wanted it to have. And so this is kind of the origin of Zod. And then as Zod got more popular, it was clear that it was being used primarily by other people who were really interested in trying to have better tooling for doing static and runtime validation at the same time, and primarily trying to write APIs that are totally non-redundant. So full end-to-end type safety, where the client is able to know exactly what the type is of the data that it's getting from your TypeScript server. The fact that around this time, people started really writing their front end and back ends, both in TypeScript, enabled some new patterns that really let you do code sharing between your client and server, and that code would include TypeScript types themselves. So I'm getting a little ahead of myself, but we'll talk about what I mean in a sec. First, let's talk about what I don't mean. This would be a fairly reasonable way for me to have written a simple API back in 2019, say if I wasn't using TypeScript. And just for as I go forward, on the left is going to be always the client code, and on the right is going to be the server code. So this is just a really simple example using Express, which if there's people here who've only ever used Next.js or something, they may not even know what Express is. But this is a real simple way to implement a REST API here. So we're basically defining a single route, a get route. And what it does is it just calls res.send on an object. And so when an HTTP request comes into /route, it'll just send back that object tuna, which turned out to be a really good choice of random semi-interesting word to have in my sample data, because I don't know if anyone tried the spicy tuna hors d'oeuvres. They were so good. There's more. I'm going to go for them after this. So on the right, Simple Express app, no TypeScript here. This is all basically just JavaScript code. Of course, if you did have these in a .ts file, over here on the left, so a simple React component, it's using React query to actually hit that endpoint and pull the data out of it. And data there is, it's any. There's no type safety, because how would it have any idea what that data object actually is? If you told someone, oh, you're using JavaScript, you should really use TypeScript instead, and make sure that everything is fully typed, they may give you something like this. And this is kind of what you may hear a lot of people use as a definition for what end-to-end type safety is. Your interface. By interface here, I just mean the interface between your client and server. Ultimately, the server will return some data to an incoming request, and then that gets serialized over HTTP and then deserialized on the client. So that's an interface. If you tell someone interface should be typed, they might do something like this. They write out by hand their tuna type, and then they maybe run some SQL query. That SQL query is just a string. There's no way for your TypeScript code to know what the expected type is that it should expect back from this random SQL query. And so what they end up doing is just casting it with as tuna. But a lot of people would say, yeah, this is end-to-end type safe, because you're using that cast, sure, but ultimately all you have to do is make sure that the data coming out of that SQL query aligns with tuna. And then there's only one definition of tuna, and you can import that type directly into your client. In fact, right here, this is a really simple example. You can just kind of imagine, on the left is client.ts, on the right is server.ts. But fun fact, this import type statement, you can import a type from any TypeScript file on your entire file system if you wanted to. And pretty much every build tool and everything will be happy to do that and build just fine. I don't know if people are used to create React app. It doesn't let you import stuff from outside of your create React app directory. Doesn't apply to import type, because import type is a statement in TypeScript that is guaranteed to always get eliminated from your JavaScript code that actually runs. So import type, you can literally use it on any file, import from any file on your file system. Sorry, end aside. So we got here a fully typed interface. Ultimately though, this is not what I would consider end-to-end type safe. You're still using a TypeScript cast. You need to update that type every time you change this query. And this is an unsafe practice. It's unsafe to have to change things more than once when you want to make a change. So this is kind of what I was getting at. You need more than just types in your files. You need to make sure that the types in question are trustable. The way to do this that people first landed on is have a nice intermediate layer that your client and your server can agree on. And this is GraphQL. This is old school GraphQL, like when the package was just called GraphQL on NPM. And it was the kind of reference implementation. I don't know if anyone has used this particular package in a while, but when I first learned about GraphQL, this is how I was told to build my API. And it was, I would say, aggressively upsetting to me, because you've got to define your entire GraphQL schema, including all your queries and all your types, as a string, and then just work really hard to make sure that this big resolvers object agrees exactly with what your GraphQL schema is. And it's very much, you're using literally a string to a string GraphQL schema to set constraints on what your code should be doing. And it does work when you actually get your resolvers properly implemented, but you've got that same problem again, where you make a change to your GraphQL schema, you also need to make sure to update your code. And when you have to change things in more than one place, bugs happen. Yeah, I'm sure, well, I guess I'm getting ahead of myself, but this schema object that comes out of make executable schema is what you use to ultimately process incoming requests. to /GraphQL, and it makes sure that the types that are expected, it ensures at runtime that everything is in agreement with your schema. And then, because it's GraphQL, you can then introspect your schema on the client, do some code gen, whatever, and run queries in a way that are type safe. And it does that by having GraphQL sit between your server and your client. A nice way that may be a little more fun is that you can actually use a framework, a TypeScript framework that's code first for defining your GraphQL schemas. And basically, in a perfect world, this would work fine. This is type GraphQL. Has anyone used type GraphQL? Yeah, okay. I had no idea how popular this was, or what the new hotness is for code first TypeScript GraphQL frameworks, but this is what I used back in the day. And I briefly thought it was a holy grail where I could write out in code all of my GraphQL resolvers, and everything is kind of I don't need to write that GraphQL schema as a string anymore. And I thought that was fantastic. But ultimately, I hit against the problem that's being laid out here, which is you end up with a lot of redundant types. So I've got object type here, which is just uses the type keyword in GraphQL for fish. But then if I want to have an endpoint to create a new fish to insert into my database, it's basically all the same stuff again, but without an ID field. And this is like a weirdly under-discussed hard problem of computer science, which is, you want a lot, you need a lot of very subtly different variants of the same set of types when you start trying to do end-to-end type safety. You may want the type that's the fish type, which has an ID, has its name and attribute, and that's how it's stored in the database. And if you do a select star, you end up with something that looks kind of like an instance of class fish. But you also need the version of that with no ID for the endpoint that you hit to actually create a new one. And then a totally different thing, a partial version of that for an update fish. And so ultimately, this approach of implementing all of your GraphQL types or your queries and mutations as classes, I think falls flat. I think there's probably room for some sort of TypeScript GraphQL framework that doesn't have this problem with classes and makes it easy to do something like you can do in Zod, where schemas are not classes, schemas are just objects and they have methods on them. And so you could define that fish type and then just pull out the ID field to generate your create input. As far as I know, that doesn't exist, but come find me afterwards if you guys have a really good GraphQL framework for TypeScript that solves this problem. Right. So ultimately, nothing should be redundant. Even when you're using a code first GraphQL framework, things can be pretty redundant. Let's talk about, no, this is a very funny joke. I'm very proud of this. Let's jump into modern approaches to end-to-end type safety. I'm guessing most of you guys have heard of a lot of these. So quick survey here, Next.js API routes do a pretty good job. An API route is just, a function in, rather a file in a special place in your Next.js, file system router. You do a default export of the handler function. And it has a bit of a problem, which is that the data that you want to return from your API route, you just pass it into res.status.json. So it's not a function that you return, that has an actual return type. And so if you, for instance, just returned an object literal, or say took that object literal, name tuna, whatever, and put it directly into the .json method over here, there's no way to ever retrieve the type of that object again, which is why I'm using this pattern here where I split out into a separate get fish function. And we're then able to, actually use the return type built in from TypeScript, which gives us the return type. Because it's an async function, we do awaited, which kind of pulls out the promise. And so you can use a pattern like this. You can actually extract the return type, assign it to tuna, and then import that into your client. And this is pretty good. I think having to pull out your actual logic into a separate function is just kind of a drag, honestly. Let's go to one that solves this problem, Remix loaders. Remix is a new hotness. They're really, weirdly, even though they solved a lot of other problems with nested routes in Next.js, the original version of Remix until somewhat recently still had the same problem where you had to split out your logic into a separate function. And it's so close too. It doesn't do the res.status.send thing anymore. You have a loader function where you're returning a value from it, but they use this JSON function. This is something that they export, and it's not generic. So the return type of JSON, when you pass in the kind of payload from your endpoint, is always just a plain web standard response object. So it's just an instance of response, and there's no way to know what data has been packed into that response, which was a bit of a bummer. So you end up having to use the same pattern until I put in a PR that thankfully the Remix team was amenable to, which basically overloaded that JSON function. So instead of returning a plain response object, it kind of had the actual type of the data that you passed into it kind of attached to it. And then later on, what you could do when you're calling use loader data is just pass in as a type hint there, type of loader. It would be able to see, okay, this loader is returning a response that returns an object with, name string, attribute string. And so now we got rid of some lines of code, and Remix is probably one of the number two in terms of just ease of use in terms of end-to-end type safety. Though ultimately the loader still runs on the server only. This is server side rendered here, and they do some magic where when a given route, when you ping a given route of your Remix app, it'll basically run all of your loaders in parallel, and then kind of pass all that down, and you render the page. So this isn't. If you wanted to build a single page application that's a little more conventional, I guess, or you, for whatever reason, don't want your dashboard for your startup to be all server side loaded, then you could use tRPC. Who's heard of tRPC in here? All right, good chunk. tRPC is, I wrote the first version of this a couple of years ago and then handed it off to someone who fortunately was a lot more committed than I was to making it a thing. Which is a great strategy that I encourage people to try, because maintaining Zod is hard enough, and tRPC would never have happened if I actually tried to keep working on it on my own. This is kind of what it looks like. It kind of has a vaguely, I guess it's not really true anymore. I was going to say it's a vaguely Express-inspired API over there on the right. You create a router, and then you kind of define procedures. And a procedure is very simple. It's just a name, in this case, fish. And then that's associated with essentially just a TypeScript function that returns some data. And the nice thing about this is you have all of your procedures defined in a single router. And then what you do is you take that type app router, you export it from your file, and that is all the type information of your entire API. And it was fully inferred in the sense that you've got this t.procedure.query call over there. It just returns this literal object. It is able to know that that is the return type of the fish procedure. And if you add a bunch more procedures there, then they're all baked into this app router type that you can export. And then you can import that type on the client side, and then pass it into create tRPC React like that. There's actually different APIs depending on whether you want to use it for React or just have a simple client that isn't coupled to React, in which case you just kind of can shoot off requests and get the data back, as opposed to the hook that you see here, the use query hook. And so in case you're wondering, by the way, you have to use the context API to actually tell tRPC, what the endpoint is, which is why you don't see any, localhost 3000 over there on the left. It's just assuming that you've already set things up with the context API. So this is what tRPC looks like, and it's pretty close to perfect if you have separation between your client code and your server code. Remix is kind of its own thing because everything is kind of intermixed. So I would say currently Next.js, Remix routes, and then tRPC are the big three kind of modern approaches to end-to-end type safety. And it's great to see it, frankly. Great to see that there are all of these options that I think are all good. So that's my extremely long answer to what is end-to-end type safety. A little aside here about why why RPC was the way to go and why it's kind of hard to do end-to-end type safety on REST APIs. It's just a matter of like API design and simplicity. Like an RPC API, every endpoint is just, it has a name and it has like an input, and I suppose an inferred output type. Whereas REST, all the data that's required to make a REST request over HTTP is kind of split across all these different places, where you have your HTTP verb, which is very meaningful. You've got URL path parameters, which store certain information, usually IDs or what have you. You've got your query parameters, and then possibly a request body for a post request. And when you just start trying to design an API to do this, like, back in this example here, we can just do tRPC.fish.use query. This is the previous slide. If we were trying to, have some API for pinging a certain URL endpoint, that endpoint is associated with like a URL string, and you could maybe get auto completion on that. But then you separately need to like pass in what the query parameters should be depending on your path. All this to say, I would say the most noble effort to have strongly typed REST APIs is Zadios, which is something to look into if you refuse to let REST APIs die, and or for other technical reasons want to be using it. So this is a bit of a philosophical tangent, which is just there's not a lot of ways you can have trust in types in TypeScript, because TypeScript is ultimately kind of a lie. You can assign any type to any object. You can then take that object and cast it to any, and change all the data that's happening under the hood. And so there's all sorts of stuff, all sorts of bad stuff that can happen. And TypeScript is just there as a development time convenience with absolutely no way to enforce its own types at runtime. There's a few times where the types that TypeScript is telling you can really be trusted. And that's basically the outputs of schema validation libraries like Zod or Yup or IOTS or what have you. There's a big slew of them out there. And then the other big one and the primary source of type safety in your application is your database. So, having worked on Zod and having, continuing to maintain Zod, I kind of was interested in the first part of this. And now my day job, I'm fortunate enough to have a day job which is working on the second part of this, which is the other big source of type safety. And that company is EdgeDB. And I just, want to quickly evaluate some of the good options out there for, I guess, interacting in your database in a way that is fully typed, because ultimately, you need to hit your database and you need to have types come out of that query that you can trust, so that you can pass them into tRPC or Remix, so that you can extract them and use them in your client to inform your React component. Ultimately, it all traces back to having good tools for actually having strongly typed queries hitting your database. And so Prisma is pretty much the most popular ORM out there by a wide margin right now. This is just a simple, select example here. You're selecting from the fish type and pulling out the name of the attribute type. So this would all work exactly as is. No typecast necessary, anything like that. I work on basically the Prisma alternative that solves some of its limitations. And so the foundation of all that is EdgeDB, which is a database that has a declarative schema, not unlike your Prisma schema. So this is EdgeDB's kind of schema definition language, kind of a simple, that extending content is supposed to be there, so ignore that. But yeah, really simple 2 types here. You've got a title and a release here. And then you've got what we call a link, which is, like a relation in an ORM model. And so here's just a really simple schema. Similar to Prisma, we have a migration system as well. So you edit this directly, you create a new migration, you apply it to your database. And then where I come in is you are able to generate a strongly typed client from your EdgeDB instance. It just generates source code either in TypeScript or JavaScript with type declarations or whatever you need, and it all drops it into this this one file where you can import the e variable. And so you may see some, it may look a little Zod-like to people who've used Zod. I'm just a fan of the one-letter variable that has a bunch of stuff on it. So this is kind of what it looks like. You create your actual database client, which you could just, do client.query and pass in your query as a string, just like with a lot of SQL clients. But here what we're doing, we're actually defining this query with the EdgeDB query builder. It's all fully, you can see the type signature of this query over there on the right. Something notable here is, it tries to mirror EdgeQL as closely as possible. EdgeQL is the query language, which is kind of like if SQL and GraphQL had a baby. And so I'm not going to show the generated EdgeQL queries here, but ultimately it's kind of like the lifeblood of the query builder, in that it would be very hard to have this same API to generate SQL queries, because SQL itself has limitations that make it hard to write any sort of composable TypeScript API that looks friendly like this or like Prisma. And so it's nice that this is actually pretty close to what the EdgeQL query that gets generated actually looks like. Here we're just, selecting the properties, and then we've got that actors link. And if we wanted to add some filters onto this, we'll actually see what that looks like here in a sec. Here's another quick query here. Kind of like Prisma, we do name true just to tell it to fetch name. Unlike Prisma, we can do a bunch of other stuff. We can do computed properties. So you've got upper name here. This is why, to go back a slide, you might have been wondering why the second argument to e.select is a function instead of, like in Prisma, it's just kind of an object, like a params object you pass in. It's a function because when you want to do interesting stuff, you need a reference to what you're selecting. Person is kind of the scope of this query. And so you can just reference its names, person.name, person.acted in, inside of other expressions. So acted in is, I guess I forgot that in the schema too, but it's a link out to all of the movies that a given person object is in. And so we can just count those up and just assign that to num credits. Similarly, we can use any sort of functions that are baked into EdgeDB, and it has near feature parity with SQL. So this is just a simple function, stir upper, string upper, that converts a string to uppercase. You have access to the whole standard library of operators and functions, and you can just compose these expressions in your queries. Similarly, we can write a filter here that would look horrifying in any ORM I've ever used, which is we're now, what this filter clause does, it selects every person who's been in a movie with Keanu Reeves, who's like been in the same movie as him. And this is using a EdgeQL construct called a path, which we've kind of replicated that same kind of syntax here. So we've got person, which is a reference to the scope, and then person.acted_in gives us back the set of all the movies that a given person is acted in. And then .actors on that gives us the set of all actors in the movies that a person is acted in. And then when we call .name on that, it's all the names of the actors in the movie that a person is acted in. And we can just check if Keanu Reeves is in that set. And this isn't doing any of this filtering or logic on the client. This is just, I could take this query object and call .toEdgeQL, and it just returns a string, which is the EdgeQL query. And ultimately, when you call .run, all it's doing is converting this whole big symbolic object to a query and then executing it using the client you pass into that first argument. And then final kind of interesting thing that you won't see in your grandma's ORM is query composition. And so this is the fun thing. This is the reason why e.select is not the thing that you await. E.select is synchronous. It just gives you back an object that symbolically represents a query. And so here we've got 3 separate queries. We've got one to fetch Robert Downey Jr. In a select. We've got one to insert Gwyneth Paltrow in an insert. And then we insert the Iron Man object into our database. We're using e.set, which is just the result of RDJ and Gwyneth. We're gonna put them into a set and assign that to actors for a given movie. And this is the kind of stuff you can do when, when you've got EdgeQL at your back, which is the EdgeQL equivalent of this is actually not too dissimilar. The SQL equivalent of this is horrifying, and I recommend never trying to write it. All right, that'll do for now. Thank you guys for listening. Open to any questions.
All right, thank you so much, Colin. Does anyone have questions? We got time for just a few questions.
Oh, sorry. When it comes to the schema creation that you went over earlier, I noticed that a lot of it seemed kind of similar to MongoDB. And I was wondering what the advantages of doing things the way that you have presented are over MongoDB, because I use MongoDB a lot in the projects that I work on, and what you're presenting seems really interesting.
Okay, yeah. You're talking about the kind of EdgeDB schema here? Okay. Yeah, I mean, ultimately, we are primarily taking our cues from the ORM world, where you've got some declarative representation of your schema. You're kind of generating and applying migrations. Under the hood, EdgeDB is storing everything in a normalized relational way. And so it ultimately has the same performance characteristics of a relational database, for good or ill. It's been a while since I've looked at the docs for Mongo schema. Obviously, as a non-relational database, they've played a little fast and loose historically with just having schema that gets enforced at all. And do you use it such that everything that you store in MongoDB is schema full?
I've never created anything in MongoDB without a schema or without.
Gotcha. Okay. Yeah, I am curious about the adoption, the relative adoption of schema in the MongoDB community. I guess the other thing would just be having a query language that is a little more compact, which I think is a trade-off where we kind of land in a different place than MongoDB. Yeah. Yeah, for sure. And then, yeah, I mean, the fact that it is relational and, under the hood, EdgeDB kind of, everything is stored in a normalized way. Unlike in MongoDB for the most part, in terms of actually managing data, say objects in MongoDB that reference other objects. A lot of times people have a hard time with managing kind of foreign key equivalent. I'm actually not super familiar with the kind of solutions to that in application land.
Any other questions?
On the surface, this kind of looks like almost like grafting an ORM library onto the database directly. When I checked your website, it said it runs on Postgres.
Yeah,
if I'm correct. There's always a point where ORM libraries tend to, depending on the size of the application, tend to need fine tuning, I guess. Have you seen a scenario where that gets to be a problem where the ORM is not quite doing what you need, and then you have to just go beyond that? How effective is EdgeDB in dealing with those situations?
Yeah, EdgeDB ultimately runs as its own hosted process on top of Postgres, and so we have the benefit, unlike an ORM, of not being language specific. EdgeDB is 4 years old since the first commits to it, and so we only have to actually write the code to convert EdgeQL to the equivalent SQL once, and we can performance test the hell out of it. Unlike ORMs, who have to keep on doing the same thing over and over again as preference change or language preferences change or the API changes. And so basically, when we're actually doing the kind of nested EdgeQL fetching, that gets converted under the hood to joins. We basically milk Postgres for everything it's worth in terms of actually, we basically do array aggregations in order to actually run really deep and wide queries in a way that is performant and scales linearly with like the kind of depth and breadth of what you're fetching. The naive solution, which is what most ORMs, including Prisma, end up going with, they do not scale very well. And the fact that they, it's a charitable way of putting it, saying that ORMs need to go in and tweak things. A lot of times there's no tweaks that can fix, for instance, the fact that they do like another round trip query to the database for every level of depth that you're fetching, which is that one hurts. That hurts performance a lot. Ultimately, EdgeDB wins that just in the first order factor here is SQL gets converted into a single SQL query that can get executed in a single round trip. And so in terms of performance comparisons to ORMs, we actually have some benchmarks called IMD bench because it's kind of an IMDb data set that you should be able to find that I think will be interesting to you. Thank you.
Is EdgeDB ready? Can we use it tomorrow?
Oh, it's ready. It's 2.0. Yeah, we're past 1.0 now. Yeah.
It is 2.0. That's great.
Right.
Let's give it up for Colin again. Thank you so much. And hopefully you make your flight. All right. So our next speaker is right here from Checker. He's going to talk to us about effortless server state handling with React query and hooks. Let's give it up for Fernando De La Madrid.
Check. Yeah, it's good. Cool.
All right, let's try that again. And please join me in welcoming Fernando De La Madrid.
Hi, everyone. I'm Fernando, and I'm from Checker, and I'm a senior software engineer, and I'm part of the UI platform team, which is mainly a front-end focused team here at Checker. And today, like we said, we're going to be talking about React query, a little bit of hooks, and also a little bit of handling state management and server state. So just a small disclaimer, I think you'll love this talk if you like things like effortless state management, writing less code, simplified reusable solutions, and hopefully improving your application performance. So part of the agenda, like I mentioned, is we're going to talk about React query, a little bit of intro, a basic intro of what it is for people that are not so familiar with it, the main benefits of the library, as well as some implementation patterns that we have used here at Checker, and hopefully some state management as well. And afterwards, I'll present a little bit of a migration that we just did recently from using Redux to React query to handle their server state. And finally, at the end, some questions. So React query. What is actually React query? So React query is a data fetching library for React. It provides a powerful and reusable hooks for things like fetching, catching, and updating synchronous data. It can also coexist with state management solutions like Redux. There's no harm in having React query and another state management library coexist on the same application. Initially, it seems like a really simple library. However, it is packed with really complex features, which handles most of the server state management that you might find in most React applications these days. So what were some of the value benefits that we were assessing when we decided to transition to React Query Hero Checker? And I think the biggest one for us was simplification. We thought that React Query was hands down the best library to handle server state in a really simple way. It also helped us handling complex operations like refetching, retries, stale data, and handling other things. It also helps with app optimization. It really does a great job providing functionality like pulling, invalidating cache, and also prefetching data and declaring data as stale. At the end, we realized that it could also be a replacement for state management, not only on the server side, but also for client information. I do not recommend like the React Query for completely handling your application state, but it's also an option if you need to. So maybe some of you might be familiar with this quote. There's only two hard things in computer science: cache invalidation and naming things. And at least we're getting some help from React Query on the first one. So let's talk about some patterns that we have implemented here at Checker. So let's start with a really, really simple and basic pattern. For this one, we'll be leveraging the native fetch API. And just as a quick note, we're going to be using a lot of examples related to candies for this. So let's assume that we're working on a candy store. So in order to fetch some data from React Query, you have to call the use query hook. And the use query hook takes two parameters. The first one, which is the key, and the second one, which is the request that we just previously defined with the native fetch API. And the key is really important because it has to be a unique identifier in order to tell the React Query cache how to properly store the data in the cache. And for this case, we're just using the string get canvas. And as you can see, immediately out of the box, we're getting a lot of things that we just need. We're getting the data, the loading state, the error state, and pretty much this covers most of the use cases when interacting with a basic API. But if you need more, the response object also provides you with a refetch function, the previous data from the query if it was done before, and much more data in case you need to. So this is the same exact example as the previous one, but it's even a little bit more simplified. For this one, we're leveraging Axios for the request. And this is just to prove and demonstrate that React Query plays well with any request that you might compose. So it gives you the freedom and the flexibility to use any external third-party library to handle the request and just pass it into React Query. Moving on to a more customizable approach, you can create your own custom hooks. And you might want to say, like, why do I need to create my own custom hooks for React Query? So first of all, it's not ideal to be calling the use query or the use mutation hooks directly into your React components. So you might want to extract that into its own custom hook. You can just wrap them up, and it will present a clear separation of concerns. You'll have your data layer on one side and your presentation layer on the other side. It also removed the need to import just any fetch or any API interaction directly into your React components. And additionally, it allows you to reuse complex logic operations that you might be doing inside of the custom hook. And just to explain a little bit of what's going on in here, we have a custom hook that requires a category for the unique ID, meaning that if you call use get bestseller candies anywhere in your application, you can pass a different category, meaning that you can store that data in the cache with different category sets. We're also filtering and renaming the data. And finally, at the end, we're just returning what we care about. Since it's our own custom hook, we can pretty much return anything that we need to. In this case, we're returning the filtered data, which we're calling bestseller candies, and we're just returning the loaded state. So moving into a more advanced use case, this example lets React Query shine a little bit more. For this one, we have two different requests. The first request is the fetch chocolate one, and the second one is the fetch brands. As you can see, the second request depends on the first one, since we require the chocolate ID in order to properly get the brands from our API. And you also might think that these two requests are being run in parallel, because we're calling our use query hook at the beginning and after the chocolate request, and we're also returning the second use query hook. So you might think that they're both running at the same time, even though we need the ID for the second one. But as you can see, we're leveraging the enable option from React Query, which is expecting a Boolean value, meaning that the query will not actually be fetched unless this value is true. In this case, this query will never get fired unless we have a chocolate ID and the user has the right permissions. It also is leveraging, this example is also leveraging the stale data property, meaning that we can set this data as a stale after 1 minute it has been passed. And finally, this is one of the features that I like the most. It's really helpful for handling side effects. And here we can have 2 callbacks, one for on success and one for on error. And once this query is completed, we can pretty much trigger any side effect that we want to in any of these callbacks. And for this case, we're just toasting a notification after the query is done. So let's talk about prop drilling. I think a lot of people in React complain about prop drilling. And it's also a really nice feature from this custom hooks. Since they're really reusable, you can pretty much call the custom hooks anywhere from your application or in any component that you may like to, which means you can avoid things like prop drilling or just reaching out for a state management solution when you're reusing some simple data from the API. In this example, we're calling our use fetch bubblegum custom hook at the top level. And this is kind of like the main component. This is kind of like the parent component, which is the bubblegum page. And as you can see, we're calling our custom hook, we're getting the loaded state. And based on the loading state, we're deciding whether we should render our children or not. And if you look closely, all of the children's, the info component, the error component, the brand components, all of them are using or are calling the use fetch bubblegum individually. And all of them are using a different piece of state. But the cool thing is that React Query is only performing one API call since the data is already being cached. So you don't have to pass any props or you don't have to go for the context API for something simple like this. So talking about state management solutions, I personally don't think that React Query is a replacement for Redux or for any other state management library, but that doesn't mean that we cannot take advantage of its caching mechanism. In this example, we are not actually using an asynchronous function. We're just passing a synchronous function as the second argument for use query. And that's the trick on this example. So if we try to leverage the cache, you can do something really cool. Here at Checker, we use the React Context API mostly for state management, but sometimes you just want to share 1 or 2 pieces of data between components. And it could be a hassle to create a new context, set up a provider, and do all the boilerplate that you need to share some state that it might not be ideal. For those simple use cases, it's okay to just leverage the React Query Cache to do some state management. Here, this is a custom hook that we created here internally. And it's just use React Query Global State Hook. It takes a key and an initial data. And the key is what we have been talking about. It's a unique identifier to properly store the data in the React Query Cache. And we're returning an array of a getter and a setter, kind of mimicking what use state does. And for the first one, for the getter, we're just calling use query, passing our key to store the data. And we're passing a synchronous function just to return the initial data that we passed. And for the setter, we're just returning a callback that takes a value and is just taking that value and storing it in the cache. And just to demonstrate how this works, we created 2 very simple components just to showcase this. And the first one is just calling that custom hooks and is using a unique key, which in this case is just reusable text, and is reading from the global state and also setting from the global state. Every time that we call the onChange function, we're actually setting that value into the global React Query Cache. And for the state viewer, we're just pretty much just using the hook to read from the global state and display that into our UI. So moving on to the part that involves the Redux migration that we did recently internally. So this is a good exercise. So raise your hands if you like Redux. And there's no shame on it. I actually like Redux. It was a really good solution when it came out. And yeah, there were reasons why we started this migration. And even though the library has evolved and it has getting better and better, there was 2 main things that were not optimal for us. It was the complexity and a lot of boilerplate code. And here we have a tweet from a guy that you might know, which is Dan Amramov, one of the co-authors of Redux. And yeah, I really identify with this tweet. Some of you might also identify. And sometimes you just want to fetch some data. It's simple and easy, right? So let's dive deeper into the reasons why. In our specific case, our Redux store was becoming our server state. We were shoving all of our server state into the Redux store, and it was just becoming an overkill, and it was not ideal for us. Also, when it comes to global state versus cache, I think that most of the newer, modern React applications don't usually need a really complex global state management solution. This can be solved with a proper cache management system, because at the end, your single source of truth tends to be not the Redux store, but the database, meaning the information that you're getting from your API. And for onboarding, it was not easy. It is not an easy experience onboarding the junior engineers or even senior engineers that have little or no experience with React. And my team here at Checker is involved in those kind of things. So for us, it was a priority to make the new engineers at Checker have less barriers to entry so they can contribute to the front end in an easy way. And the last one, which is boilerplate, I think that if you have used Redux, this kind of talks for itself. So here's how we used to handle the server state for just 2 fetch requests. On the left, we have the actions. And as you can see, we have to do everything manually. We have to define each action that we needed for the server state. We have to do when the request was going, when it was loading, and when it was error, and so on and so on. And this is just for 2 requests related to our webhooks. And on the right side, we have the reducer portion, which is actually handling the state itself. And for that one, we even have an internal utility helper. I think that you can see it, but it says helper on request, on success, on error, and it's the same pattern all over again. So this was a lot of repeated tasks, a lot of boilerplate code, and it didn't fit our needs. So this is how the code ended up looking after we refactored to React Query. And this is kind of showcasing the previous example that I showed you with the Candice example of how you can implement some different options on each hook, how you can create your own custom hooks, and how you can leverage the reusability on those 2. So for those 2 refactors, the first portion is the actual custom hook that we created. And at the bottom is just the implementation or the consumption of those hooks. We're returning the data that we need and the different server state that we might need, depending on the feature where we're consuming these hooks. And finally, this is the MR for the cleanup. We deleted 322 lines of code just for those 2 fetch requests. And as a fun fact, this is not a loop. This is just a big MR that is just going and going. And just to recap what we just talked about, React Query is a really cool library to handle server state. It actually does a great job at it. It also helps a lot with optimization since it has a lot of caching abilities, polling and prefetching. It also helps us handle complex operations like side effects, prefetching, and calling data stale. And finally, it could be a global state management alternative, even a simple one, even if you like to. And that's it.
All right. Right on, Fernando. Does anyone have any questions? Any Redux fans here?
I'm new to the Redux query things. I'm curious where the caching is. Do we have other like Redis database for that, or it's stored?
It's a client-side cache.
Okay, so my follow-up question is like how you know the caching works, because if the memory is full, it's replacing, and how you value the profiling since the performance.
Yeah, that's a good question. So you can set up the cache every time. I mean, there's the old ways and the new ways. On the old ways, you had like a one cache that you were just setting up for your entire application. And you were wrapping up your entire app with the same cache. And you had some configuration, like you said, and something that you can tweak in order to make it more to your benefits. But nowadays, you can even instantiate different React query caches depending on what you want to do. So if you instantiate a new cache for a component, then when that component mounts, you can get rid of that cache element.
Any other questions? Back here.
Thanks, that was really cool. I've never used React Query, and I was just curious, have you ever seen anyone using it with GraphQL, or is there good GraphQL support for it? Or other way around?
No, I haven't seen anyone use React Query with GraphQL. And I think that there's this kind of like the regular REST API query library that GraphQL will be it will be like a different approach per se.
Yeah.
So GraphQL is giving you a lot of these things out of the box as well.
Yeah,
but you will have to have a GraphQL API in order to interact with it and have those features. And what React Query is doing is kind of like interacting with regular REST API and giving you kind of that GraphQL experience with the return values.
Yeah, cool. Thanks.
Sure.
One more over here.
Oh, go ahead. Earlier, you said that you use the context API in order to manage state.
Sure.
Primarily. And I was wondering, is Redux what you guys were using to maintain the integrity of that state? Because I know that when I use the context API myself, that whenever the page refreshes, everything resets within the context. So is that what Redux is used for, to maintain the integrity of that state?
Yeah, you can use it for integrity of the state. In our case, that was also one thing that we didn't need for the type of application that we developed, because we were mainly needing the state from the API. So we needed that state to be, if you refresh the page, you want to like also reload the state completely, because we really needed to have the fresh data coming from the API. And we have to internally create something, an internal kind of like function. If we needed to preserve some kind of state, we'll have something preserved in local storage.
Okay.
Some settings or some minor things, but in our case, it's not a big deal. Or mainly, we don't want to preserve the state because we need the fresh data from the API. But for user preferences and some other things like that, we leverage local storage, which was not a big deal, just to store some minor state and preserve it.
Okay.
Did your team evaluate the comparable library SWR, and like what, I guess if so, what key advantages and disadvantages did you find that still tipped you in favor of React Query?
I am aware of SWR, but unfortunately, we didn't do like a deep comparison between that library. We usually have that process actually for most of the libraries that we use. But when React Query came, I think it was a no-brainer for us, and it was kind of like being adopted by a different team at the same time. So it was kind of like a perfect timing for us, and it makes sense because it was too early when we were adopting it, so we didn't have the kind of like the need to compare it to other. I know that right now, even Redux. So that's the thing. Even the new helper libraries from Redux can give you something like this, but that's the catch. You'll have to have Redux Toolkit, and more like complementary libraries that can work with Redux and give you something like this. So now I think that these days there are a lot of competitors and there are a lot of libraries that are doing the same thing. But from what I've seen, the one that still, I think that the one that bundles faster and that gives you quicker updates, at least from our perspective more recently, has been React Query. I don't know if it's related because they were so early into doing this approach and then just like keeping up with that momentum, but we haven't had a need to even look aside to get another library.
Okay, yeah, thanks.
All right, everyone, let's give it up for Fernando. All right, so we have one more special session for you this evening. We are going to flip the stage here very quickly for us to engage in a fireside chat. This shouldn't take long at all. Look at all these hands we got. Yeah. All right, that was fast. Thank you, everyone.
That was super fast.
How about a round of applause for Checker? Okay, is that us hitting each other?
Maybe.
Let's move away from each other a little bit. Let's social distance a little. Are we on the camera still? What's that? Yeah. Let's try this one more time. That's like that. No. These are sensitive. Let me try with this mic.
Maybe we can just both share that mic.
Testing. All right. Yeah, if you're more comfortable taking it off. All right, that was fun. So our next segment is a fireside chat about senior engineering. Being a senior engineer takes experience, knowledge, and skill. But more than that, being a senior engineer is about having a specific mindset. Fortunately, we have someone with us today who has written a book on that very subject. Swiz is a senior software engineer at TIA. TIA is a modern healthcare startup for women, and you can learn more about them at asktia.com. Swiz joined TIA when it was just a startup of 40 employees, and now they employ hundreds of professionals, including nurses, doctors, and software engineers. They're a very exciting startup and has recently raised $100 million Series B. Swiz is a software educator who has trained engineering teams on technical subjects including React, Redux, GraphQL, Jamstack, and more. He often blogs about his lessons on software engineering on Swizec.com. Over the past few years, Swiz has blogged more about leadership, career advice, and general learnings and observations of his ascendancy to senior engineer. He has aggregated those essays into a book called Senior Engineering Mindset. That's a long-winded way of saying I'm delighted to have Swiz Teller here with us to talk more about senior engineering. Swiz, welcome. So,
no, so much louder.
so you've been coding for over 2 decades.
Mhm.
What is it you love about being a software engineer?
So I think my favorite thing about being a software engineer is that it makes it very easy to go from an idea to something that actually works and does things for people. And I kind of started when I was 9-ish. We had a coding class in school, and then I basically just never stopped because it's really fun and there's always something new. And then the last couple of years with the web becoming super popular, I think I was in high school when the web started getting going. And it's just so cool. You can just build something, put it up on the web, and then there's a URL, you give it to a person and they can see what you made. And that's just, I don't think any other profession really gets that.
I wholeheartedly agree. So let's start with some definitions. What is a senior engineer?
So a senior engineer kind of depends a little on who you ask. It's what they call a terminal job title or a terminal level, because you can get to senior software engineer and then just stay there for the rest of your career. It's kind of like if you're a doctor, once you go through the intern and the attendee and all of that stuff, and then you're just a doctor and you stay a doctor forever. It's similar with software engineer. It's someone usually between 5 and 50 years of experience. The most basic definition is usually that senior software engineer is somebody who can run their own projects. You can give them kind of requirements and say, yo, we need to solve this problem. And a senior software engineer should be able to take a fuzzy description of a problem and find a solution for that and implement it, adapt it to your system and all of that stuff.
So someone who's capable, who's independent, who can implement things on their own. Let's define some of the other characteristics of a senior engineer. Is there anything else you can think of that would delineate one from being a junior, maybe even mid-level engineer to being
a
senior?
Junior or associate engineers usually are people who can write code. They can write really good code, but it's not so much about how long it takes them, but they need more guidance and more guardrails. Like you wouldn't ask an associate to like, hey, design the next Google for me. It's more like, hey, we need this button on a page, go figure it out. Then someone who's more mid-level can follow specs and follow like it's essentially about the scope of the problem that you're solving. So then in senior and senior plus and above, that's where you start getting into the area where people are like somewhere between purely focused on the code and starting to become more focused on the business problem. And you get interesting questions like, hey, there's 5 different solutions to this problem that would all be valid. Which one of these fits our constraints the best? Or which one of these is the best choice for our team specifically because of what kind of people we have on the team, because of what kind of trajectory we have for the company, or like what skills we have, that sort of thing. And at the same time, what fits within our budget. Like a very, A very typical differentiator between someone who's like a mid-level or a senior engineer is whether they can fit the solution into the constraints. Mid-levels are often, and a lot of seniors as well, this may be more of a Silicon Valley thing than a specifically senior engineer thing, but a lot of engineers get very focused on writing perfect, amazing code, but not on, hey, is it actually worth spending so much effort on this thing that we're going to throw away next week because it's a marketing page for Dreamforce? You probably don't need to spend as much time building something like that as you do like your checkout system that's going to keep running for the next 10 years.
So discernment. Is the title of senior engineer granted by a company to an engineer, or is it more self-declared by the engineer themselves?
Well, in the end, titles are always given, but I feel like it's kind of taken in that managers usually look at the people they have on the team and they see who has the potential. And if you're the kind of person who takes on those bigger challenges or who steps up and volunteers and says, oh, that annoying task that nobody wants to do, but is going to make everyone on the team faster, I'm going to take like an extra hour, not necessarily outside work, but just I'm going to find the time during my work hours to do that extra stuff that's annoying everyone, but nobody's fixing. And then if you're the kind of person who takes that initiative, you automatically start getting more responsibilities and more people reaching out to you. And as you gain those more responsibilities, that's primarily where the bigger titles come from.
Do other engineers typically report to a senior engineer?
Usually not. So senior engineers can kind of take on the role of a tech lead on a team or leading a project that potentially even spans multiple teams, but they're not really people managers. It's more like managing the technical aspects, maybe running the project management part, depending on company size and culture. Like a lot of times you're like making sure as a senior engineer, you're often owning the project and responsible for its delivery, even though you're not the person who's writing all of the code. But that's different than being a people manager, which is where you think about people managers think more about the structure of teams, and they also make hiring, firing decisions and so on. Senior engineer is more like project focused, making sure a project gets done well and on time, rather than constructing a team.
So people aren't reporting to them. They're reporting to the same manager as their junior counterparts, as their mid-level counterparts. Mm-hmm. Is there any sense of, at least in the companies in your experience that you've worked at and that you've heard of, that people that you know, is there any change in dynamicism when you get to that position?
Yes, I think there is a change in some of those dynamics. I've heard people call it's like being a manager without the authority of a manager. So you have to use a lot of your soft influence and kind of soft leadership skills to get projects done and make sure they run well. And that kind of automatically changes the dynamics, because people can start deferring to you, which can be good or bad depending on how you do it. Like if you're making all of the best amazing decisions, that's great. People just defer to you. But it's also very unlikely that you as a single person can be smarter than your entire team. So it's a lot about encouraging people to speak up and say, yo, Swiz, you are wrong. This is the stupidest idea I've ever heard. So it can be hard to find that balance, because I don't know, maybe it's just the people I've worked with, or it seems like as you get more experienced, or if you happen to be one of the more experienced people on the team, people automatically think you know what you're doing, but you may not actually know what you're doing. And the best kind of problems to solve are the ones where you don't know what you're doing, because nobody knows how that problem should be solved. So I think that can be interesting. I'm also not sure if I actually answered your question.
It's okay. How does a senior engineer differ from a lead engineer, or is there a difference?
So yes, that's again where titles come into play. often, so in modern companies, the way it usually works is that you first do the job of the next level, and then you get promoted as confirmation that this is the level you can operate on. Nobody wants to promote somebody to lead engineer and then like, oh crap, this person can't actually do lead engineer jobs. Do we demote them? Demotions are very rare in, I think, probably in all of tech. I don't know how it works in other industries. So demotions are rare, so people are very careful about who they promote. So the difference between someone who's a senior, like if you just became a senior, there's a big difference between being a senior and being a lead. If you've been senior for a long time, it's very common that you kind of softly, gently start getting pushed towards those lead roles, especially if you can actually pull them off. And then eventually, based on company needs or whatever, you may get promoted to lead engineer. But it's more, in most companies, it's more of a role than an actual job title.
You mentioned in your book, Senior Engineering Mindset, that software is a tool, not a goal. That this tool solves the problem the business needs, which in turn serves customers. Where does the senior engineer fall in these responsibilities of product features and design versus product development? Should they act as a bridge between these two worlds, or should they stick to the technical specs and implementation details?
Oh, very nice. So I think this is actually one of those shifts that are happening in the industry, where in the olden days or in companies that are not like quote unquote tech companies, you have product managers handing off specs to engineers, and then engineers implementing based on those specs. In more modern companies, the product manager or the product owner is actually part of the team itself. So you are peers with the person so the product owner is responsible for analyzing the market and understanding what the market needs. And then they collaboratively work with the engineers to figure out what is the best way to solve that problem for the market. And then you iterate together on the solution to find better solutions.
So you're seeing it as a collaborative, iterative
Yeah,
process.
exactly.
It's cross-functional rather than, here's the specs.
Exactly.
Coded monkeys.
I think the exact words I used in the book is that you're supposed to be a partner to your product manager or to your product owner, where a lot of it is the product owner comes to you with an idea, hey, let's go build this. As a senior engineer, you can take a step back and say, okay, so what is it that we're actually trying to solve? And then once you understand what you're trying to solve for the user, then you can propose different or better suggestions. And like one of my favorite things to do as a senior engineer is to intuit what the product manager or product owner is trying to achieve, and then finding a solution that takes 1 day instead of building the full perfect solution in 5 days or whatever your cycles are. Like finding those hacks.
And on that vein, how can meetings give you superpowers?
Yes, so the meetings are kind of the superpower, or a lot of engineers really dislike meetings, but really they're an amazing tool, because if you think of yourself as being more responsible for the output of your team rather than yourself personally, which is what senior engineers are supposed to be, and then senior plus especially. If you can have a 20-minute or a 30-minute meeting with your entire team to design a solution to the problem, so that then the entire team understands what they're doing, everyone's on the same page, everyone has had time to put in their thoughts and ideas, and and as a senior engineer, you were able to guide them to a good solution that's going to be easy to implement. Those 30 minutes are probably way more valuable than sitting at the keyboard for 5 hours and typing out code, because you can like, especially as a senior, you become much more valuable in terms of your ideas and experience and understanding the gotchas and knowing where things are going to go wrong before they go wrong, rather than how fast you can type code. And if you can use that to get others to write the actual code and use your guidance to help them write better code or help them avoid gotchas, that is much more valuable than doing it yourself.
How much does the mindset of an engineer play into whether or not they'll become a senior engineer?
Can you expand on that?
For example, leadership. Is leadership a quality that is a requisite for becoming a senior engineer? Or is that something that can be learned?
So yes, leadership to an extent does come with being a senior engineer, mostly because these days software is very collaborative. We don't, this is no longer the 90s. You're not gonna sit down like Carmack and write an entire engine for Doom 3 from scratch yourself. It's more like someone like Carmack or senior engineer is going to be responsible for creating a good engine for Doom 3, but people working on it, there's going to be like 50 of them or more. So a big part of what the senior engineer does is coordinating all of those efforts, making sure everyone's pulling in the same direction. And all of that is basically leadership. I think if you have a bunch of natural charisma, that obviously helps, but it is, I'm pretty sure it's a learnable skill. I don't know yet how to learn it if you don't have it, but I feel like a lot of it is just, hey, lead this small thing, and then you learn from experience. And then, okay, cool, you can now lead a small feature. How about you try leading a bigger feature? Ooh, how about you now try to lead a feature that actually has 3 different teams involved? And then you kind of grow from there.
Incremental gains is a force multiplier. I like it.
Mm-hmm.
If someone wants to become a senior engineer, this is in their head. This is part of their career trajectory, which
Mm-hmm.
is a lot of people who are engineers. How does a vision of their own career play into this?
Yes. So this, God, what is his name? So his last name is Hammond, Richard Hammond. So the
Top Gear guy?
the what? No.
The Top
So-
Gear is Richard Hammond now.
Yeah. So Richard Hammond is, I think it's Richard, is a famous computer scientist who invented Richard Hamming. Damn it. That's what I was getting wrong. So Hamming has a really good essay/talk called You and Your Research. And in it, he talks about how if you want to do top tier research, if you want to do good research, you need to have a vision for where it is that you want to go with your career. And it's the same thing for software engineers. If you're just randomly responding to stimuli that come from outside, you're going to walk in what they call a random drunk, like it's the perfect drunken walk is what they call it in math. It's an actual term. You can look it up, Google drunk walk, and it's basically a graph of a random process, kind of making random decisions. Do I go left? Do I go right? And doing that repeatedly, it's never going to go very far away from where it started. But if you have a vision, if you have even just like a 10% chance of making a random decision that is 10% more likely to go into a certain direction, you're going to get there much faster, or at least, or even at all. So the way vision helps in your career is if you have a vision for what you want, not just in terms of, I want to grow to be a principal engineer. It needs to be more like, I want to work on these kinds of problems. This is the thing that I want to solve. If you have that sort of vision, you can then find companies who will hire you to do that. And you can move in that direction and make your mark on the engineering world as a whole, not just on your career.
So Swiz, you are now a senior engineer.
Yes.
What is your career vision? What's the next step?
Yeah, so I'm more of a tech lead these days, really, than a senior engineer. There's sometimes I deliver entire stories without typing a single line of code because I just never get to it. And that's really cool because my team has really puts in a lot of work so that I can focus on the bigger picture and they focus on the stuff that honestly after 20 years has become a little less interesting, like how to write a for loop. Yeah, not that interesting of a debate. How to model your data so that we can write a consistent for loop across 20 different microservices, and this is going to evolve over the next 10 years of the startup's lifetime. That's a lot more interesting. So while I essentially use my team to use is a bad word, but I leverage my team to create time for me to focus on the bigger picture and think about those bigger problems so that so that I'm not bogged down in the details. So I think what that boils down to is that my trajectory, my desired trajectory, is probably something like a principal engineer, or maybe if I find the right kind of startup, more on the VP side. I kind of like, as I've been working more on more collaborative teams, the management side, the people management side, has become more interesting than it used to be when I was on different teams. So potentially startup executive would be cool, someone like who's responsible for really big technical decisions. Like an interesting thing I've learned as our team has grown in the last 2 years is that the way you scale engineering teams is actually a technical problem, not as much a people problem as I thought it was. So that's super interesting. And then, yeah, kind of in that direction, bigger, better decisions, more impact, that sort of thing.
Very nice. So at TIA, you've overseen a company grow from 40 to 400. How has your work and responsibilities changed over that time?
Yeah, so the team has grown that much in just over 2 years, which still kind of blows my mind. And an interesting aspect of this happening during COVID times is that you don't really notice that the team is growing. It's just the number of people on Slack in the general channel is going up. And it's like, oh, cool. There's 400 of us here now. That's crazy. But what's been interesting is that when I joined the engineering team, there were 8 of us in total. So it was very much like everyone owns huge swaths of everything. And one of my first projects was, hey, we have this huge jQuery app, move it to figure out how to, and then start moving it over to React. And one of my roles was laying the groundwork and setting everything up for our React infrastructure, then training the whole company on using React, then hiring React people, guiding the new people into my weird ideas of what React should look like, getting everyone on board with that, and kind of building the entire system. Now that the front end is in a good place, I've been spending a lot of time on like the backend side, splitting that into microservices. I'm still trying to get us on TypeScript. Turns out turning a 1 million lines of code plus code base from JavaScript to TypeScript is not quick. So we're figuring out how to do that. Yeah, and a lot of it has just been dealing with, as the company has grown, the challenges that we have and the integrations we have to build, the kind of systems, how many people are touching the code has been changing a lot. So I've been focused a lot on just how to enable growth, how to make sure that tech is not the reason that we that we fall off our trajectory.
Maybe we can train GPT-3 to do your.
That would be amazing.
Your code change. So I'm interested in talking about visas just for a brief moment. So there are many people in the Bay Area who are non-citizens. Their livelihood here is dependent on their visa status, which more often than not is tied to their employer. This is obviously quite limiting.
Mm-hmm.
But you have a unique circumstance which allows you to be a bit freer as a non-citizen immigrant here. Can you elaborate on how you sponsored your own visa?
Yes. So when I first got to the Bay Area, there's a couple of visas you can choose from. Choose is a strong word here. You basically take what you can get. And the visa I didn't want is the most common one, which is an H-1B. The problem with an H-1B is that it's based on a lottery, and especially because I didn't graduate from college, it would make it very difficult to get that visa. Because I probably wouldn't get through the lottery, and even if I did, they would be like, "You didn't graduate. That doesn't work for us." So instead, I went for a O1 visa, which is so my immigration status was essentially alien of extraordinary abilities in the arts and sciences. Yes. So I was able to get a startup to pay to sponsor that visa. And it's a visa that's based on publishing articles, giving talks all over the world, and essentially convincing the US government that you are at the top of your field. a big part of at the top of your field is how exactly you define your field. So what the lawyers try to do is try to find a very narrow field that still sounds broad enough to be a real field. So it's something like
Those titles.
I think we ended up defining my field as building high growth technical startups using React on the Jamstack or something like that. Like super specific niche. There's probably like 100 of us in the world who could say that's what we're focused on, and we probably all know each other. So it's very easy to say, I'm at the top of the field of that. Everyone else in the field knows me. So I had that at first, and then the next step was sponsoring my own through my LLC. So I essentially created a startup business as a side hustle while I had a day job.
A US LLC, right?
Yes, that was a US LLC. And then I hired different lawyers because they're not your lawyers unless you're paying them. So I hired my own lawyers to get a new O1 sponsored through my own LLC. And the trick there is that once you are the owner of the company that's sponsoring your visa, you can essentially do whatever you want. Because you can just say, yes, I am essential to this company and I am doing, and I am at the top of my field. So, you know, I deserve this visa. And then you have to prove that, yeah, so you essentially do that. And then that is still a little bit limiting because it means that you cannot be employed by a different company than your own LLC, which means, especially in the Bay Area, companies are very reluctant to hire contractors or freelancers. They much prefer to hire full-time people. Plus, most of them have the limitation that unless you're full-time, you don't get equity. And equity is a big part of why you would want to work at a startup in the Bay Area. So I was able to hire more lawyers and use the fact that I have an O1 and a bunch of additional requirements to essentially argue to get a green card that's based on an O1. So I now have a green card that says I have special abilities in blah, blah, blah. And the nice thing with a green card is that that gives you permanent residence. It also doesn't expire after 2 years like an O1 does. It's essentially for forever. And you can actually be employed by any company. So you can get equity and all of that good stuff. And once you have it, it's yours. They can't take it away anymore. Whereas with an O1, you have to reapply and reprove that you are great and amazing every 2 years, basically.
So the green card is tied to you, not your LLC.
Correct.
And they can't take that away regardless of the status of your LLC and your O1.
Yep, correct.
Amazing.
And the extra trick with turning it into an O1 was that in turning it into a green card is that there's two types of this green card. One is for people who have like Nobel prizes and stuff like that. And the other is for people who could be in that area, but are also doing work that's in the national interest. So doing the national interest waiver lets you get the green card in like a year instead of in 5+ years. And it also lets you sponsor it yourself. So you don't need any type of sponsorship. You just say, I'm cool, I'm doing stuff that's in the interest of the US government. And then if you're able to convince bureaucrats that that's true, you get a green card.
And you said that does not expire?
That never expires.
That's amazing. How long did that whole process take?
So the whole process, the first O1 took about 3 or 4 months to get everything together and get a strong enough case. The second O1 was easier because once you have it, it's very easy to say, well, you approved it before, so I should just be able to get it again. Because I was transferring it to my own LLC, we had to also prove that the LLC itself is fancy enough. So that took another 6 months or so, just to get the application. And like, this is crazy. The lawyers doing this are amazing people. It's like you give them 10 pages of evidence and they turn it into a 600-page application. And then the green card, the whole process, we started doing the green card in August. No, yeah, I think it was in April or May 2020. And then I finally got it approved and everything in May this year.
So I missed your start date. So how long was that, the whole thing?
It's like, including the waiting process, about 2 years.
2 years, okay.
Um,
When dealing with the government, that's not bad.
yeah, that's true.
Thank you for that story. That's just incredible. I think more people should know about that possibility. I'd like to circle back to a few more questions on senior engineering, then we'll open it up for any questions from the audience if you're interested. You talked about how, blogging and being a prolific writer helped you to get the visa. How has that helped you just in your career in general and, when you're in job applications and job interviews?
So I think, especially when you're trying to enter a field, just having anything out there that, like portfolio, blog, anything that shows what you can do and what you're capable of really helps. Especially if, I'm not from the US, so I had to first, I'm not from the US, I didn't graduate. So a lot of it was just working. I started working as a freelancer for US companies right after I dropped out of college. So a lot of the reason I had my blog was to show, hey, I'm a real person, I'm trustworthy. I'm not just some rando on the internet, even though I was a rando on the internet. But a lot of it is kind of like authority building and making sure that you have something to point at to show I can do this stuff. Then as you start building more of your quote unquote real experience, that usually overshadows anything you can do on your own. It doesn't matter how much I blog or how famous my blog is or all of the experiments I do, it all pales in comparison to being able to say, I saw a company grow from 40 to 400. Mm-hmm. That's gonna make hiring managers a lot more excited than, hey, I got 10,000 views from Hacker News. That's cool, right? But what the blogging does, and a big part of why I still do it, is that it helps you think through what you're learning. It helps with, it helps you grow faster. So Swizec had an interesting tweet recently where he said that it doesn't matter how experienced you are, somebody who actually looks and inspects how they work will beat you eventually because they are growing and improving faster than you are.
Operating from first principles thinking?
Yeah, first principles thinking. So that's where blogging really comes in. There's a lot of times where at work, I find a problem where we're thinking about something and then writing a blog about it helps me think through it and really form my thoughts. So the next time the same problem comes up, I am much better at arguing my case or explaining, hey, we should do it this way. And then instead of saying we should do it this way because that's what it feels like, I have a whole list of reasoned arguments that I sat and reasoned through on my own time.
Yeah, and that blog can actually help to communicate to the world that you were part of the team that grew from 40 to 400 and X, Y, and Z lessons. So unfortunately, today you didn't get the chance to sit down with Rick Tates from Netlify. I really enjoyed this conversation. Hopefully next month you'll be chatting with Rick Tates, the Senior Director of Engineering at Netlify, to talk about that. So from your vantage point of a senior engineer, what are the broad strokes that you would like to know about a role of a Senior Director of Engineering?
Yeah, so I think one of the most interesting things to find out from an engineer perspective is what is it that directors even do? Not because what they really do, I think, is a lot of invisible work where it's like, okay, we're writing all of the code. What is it that they're doing? But they are actually doing a lot. So I'm interested to hear Rick talk more about that. It would also be really interesting to see what it is that actually, what it takes to get to that level. Like how does engineering look? What does engineering look like from a director's perspective? How do they see different engineers on the team? Like what makes an engineer more visible to someone who's at director level, or what kind of things are they worried about? What are they thinking about? What keeps them up at night? And then how can we as engineers make sure that that isn't keeping them up at night? As I imagine it's very different than what I'm worried about when I close my laptop in the evening.
Great. Well, I really look forward to that next month, hopefully. Can we all give it up for Swiz for sharing his knowledge with us? Appreciate you coming out for this. If anyone has any questions, I'd like you just to come up and grab the mic so I don't have to run around and I can stay seated. Anyone want to come up?
Thank you for being here. And so I have been software engineer like 3 years, and I think my biggest challenge is like for each company I stayed there, I was kind of like trapped by their tech stack. And so sometimes I was like, oh, should I learn or go deep to this technique, or how could I like learn more generic and to be used by the other company? And another thing is like, what's your advice to choose a company to grow your like engineer skill? Yeah.
So in terms of, I think, yeah, so whether you should focus primarily on your company's tech stack, I think depends a lot on what the company is. If you're working at something like Google or Microsoft or Facebook, their internal tech stacks, from what I've heard, are so specific to the company that it's essentially non-transferable to anywhere else. Like they don't even use Git because they have such huge code bases that they have to use custom tooling for everything. So if you learn that really well, the benefit is that all of these companies are themselves so huge that you can easily build an entire career there and you will be totally fine. The nice thing is that a lot of these large companies are also constantly sharing employees. So if you get one of their stacks, if you get really good at one of their stacks, you will certainly be able to learn a new stack very quickly if you go to a different company, because there's enough similarities. But if you're working at some legacy company where you have to write a dead-end language that nobody's really talking about or using anymore, I would probably not focus on becoming an expert in that. No, I'm not going to think of any examples right now, but you can kind of tell when you're in a stack, you can tell whether it's a living stack, it's growing, it's popular, it still has vitality in it versus something that's slowly dying and on its way out. And you can build a really amazing career on ancient tech stacks, but personally, I think it's more interesting to be in a tech stack that a lot of people are using. The other thing is that as you learn more different stacks or more different libraries, or after you've been around for a while, you see these technology hype cycles, you realize that it's all roughly the same. So once you start noticing those patterns of everything being the same, if you focus on solving those patterns and on those bigger picture things, you can transfer those skills anywhere, and the specific technology is just a tiny detail about how to it becomes just a tiny detail, so it can be very quick to transfer between stacks. What was your other question again? How to choose a company. So my policy of choosing a company, and it's the same for, if you can, choosing a team within a company or a project to focus on, is to think about the concept of S-curves. S-curves are a concept from economics where things usually start growing slowly, then they explode in growth, and then they taper off again as they reach their peak. If you can join a company, project, or team at the bottom of that S-curve, right when it starts exploding, that's where you're going to learn the most, the fastest. Like I often say that the last 2 years at this company that has grown so fast, for me, feels like I gained 10 years of experience, even though it was just 2 years. It's because so much changes so quickly and so many things that you have to deal with. that makes you learn faster. So yeah, basically, your career growth is often limited by the company you're in, or like the company sets a top limit to how fast you can grow. So the faster the company is growing, the faster you can grow within the company.
Thank you for your question. Anyone else have any questions?
Thank you for taking the time for this fireside chat. You spoke to gathering consensus. That's always difficult among teams or stakeholders. Do you have any perspective on gathering consensus specifically among engineers?
So gathering consensus among engineers, as we all know, can be very difficult. Like we can probably start a fight about just about any library we can think of right now.
Tabs and spaces, man.
Yeah, tabs and spaces, yes. So I think, well, there's different tactics. I think it fundamentally depends a lot on the kind of culture you're working on and what kind of team you're in. What I find helps a lot is if you work on a team that has a lot of real deadlines and real business goals that it needs to achieve, a lot of that consensus building falls away, because rather than being focused on the minutiae and the tiny little details, people don't have time for that. It's like, yo, we really need to get this done. We need to get it out to users. We have users banging down our door. What is the best way to get it done that's good enough? And in terms of another thing that I found really helpful, once you get your team to adopt that mindset of we want to achieve business goals, not focus on technical perfection, you can save a lot of effort by saying, okay, cool, I agree with you. This is an amazing idea. Wonderful. Let's write a story and put it on our backlog for later because we don't have time for it right now. So by agreeing with them, you're validating their opinions. And by giving them a place to store that and make sure it's not forgotten, you're assuaging, you're helping their fear of not being heard. It's like, this is important to me. I don't want it to vanish. But if they put it on the backlog, and if you then actually go and repeatedly do those things or find opportunities for like, hey, we have a feature that's in that area. Didn't you make a story about this 2 months ago? With that, there's something here that we want to fix. How about, can we do it with this story? Does it fit the business perspective, the business needs right now? And as you do more of that, people are a lot more willing to kind of go with whatever works best. And the other aspect is also the Amazon principle of disagree and commit. You yourself, if you're somebody who wants to find consensus, if you're not the problem in the consensus, if you're not the thorn in everyone's sides, they're going to be much more likely to build consensus with you as well. So it's like, hey, I think this is a dumb idea, or I don't like this, but it's going to work and it's going to be good enough, so let's go with it. So a lot of it comes from people seeing that you can let go of your arguments. They're then more willing to let go of their arguments as well. And one way I like to think about it is try to aspire to be the person who, when you really dig your foot in, it's something important. Don't go on a tirade about tabs versus spaces and refactor the entire code base to spaces. Save it for when it really matters, so that people know, hey, if this is the person who's speaking up and who's complaining, we should probably listen because it's important, because you're not burning that goodwill on irrelevant things.
Thank you for your question. Anyone else?
Thank you for your time again. For someone trying to break into the industry, as of yet, there's a lot of talk about becoming a senior developer. And what my question is, as someone who is still learning, what are the best practices that we should be implementing as of right now to one day reach the skill level necessary to become a senior developer? And in regards to that too, Like, are there any sort of like general projects that we can sort of apply so that we can build that skill set? Because one of the issues that I have learning data structures and algorithms, for instance, is that when you learn a new data structure like a hash map or a node list, it's like you want to implement it right away, but there's no explanation on what type of real world scenario you should implement it in. So my question is, what should we be doing to be on the right path to becoming senior developers, and what should we be trying to work on in regards to that?
Great question. So I think maybe not the only thing, but the main thing I found that really helps with that is just build a lot of stuff. The more stuff that you build, the more random ideas, even if you don't finish it, just build shit. And the more of it you build, the more you'll see, oh, hey, I should have used the hash map here. Or, oh, hey, if I use this other data structure, or if I use this database, it makes this sort of problem easier to solve. And the more you build stuff, the easier it's going to become, and the more you build that experience, essentially. And the other side of that is that if you can find a way to get feedback, that's going to help a lot. So, for example, if you build a side project, try to actually launch it and get some people using it and see what breaks when people start clicking around, and then figure out how to fix it. If you have a friend who's in the industry, or somebody who is willing to like spend 20 minutes, 30 minutes with you reviewing some code or giving you ideas, do that. Like, build something and then go ask anyone, hey, what do you think of this? What could I have done better? And honestly, that's how we train associates / junior engineers as well. It's like, we're going to give you the best way to learn as a junior or even a mid is we're going to give you real problems to solve, and you're going to solve them, and then we're going to give you feedback. And then as you go through those cycles, you become better at it. This is also known as tacit knowledge. And honestly, as much as people like me who write books and blogs try to figure out how to teach tacit knowledge, one of the fastest ways and the easiest ways to learn it is to just keep doing the thing. There's a really good example from the chicken industry, where if you want to figure out the gender of a baby chicken, nobody actually knows how that works. But there are people in the world who can grab a baby chicken and immediately know whether it's a boy or a girl. And this is important for reasons, but the thing is that nobody has figured out what is the rule that these people are using, but one can learn it by spending 2 days with somebody who knows how to do it. And like, you grab a chicken and you say, boy, and the expert grabs the chicken and says, no, this one was a girl. And as you go through those cycles, eventually you start getting it right, and nobody knows why.
That is fascinating. I would expand on that, actually. Everything he said, do everything he said, but also build in public. No matter where you are in your career, where you are in your skill level, there is someone who's at that same exact level and will take value from any content you're providing, whether it's questions or whether it's answers. Put those questions you have out there in the public, and don't be afraid. There's always going to be the 1 or 2 troll assholes that come in and shut you down. Fuck them. Don't worry about them. There's a lot of good people out there, and there's a lot of people who will value anything you provide out there. Ask questions in public, create answers in public. Keep as many of your repositories, as many of your work open source as you can. Link to it on Twitter, get active on Twitter. When Swiz was mentioning, about joining a startup at the S-curve, you can get that same S-curve or even a parabolic hockey stick curve from social media. It takes years of consistent practice, but that's the same with anything, right? Even if nothing else, especially at the start, if you do it just for yourself, just to put it out there as a record for yourself, I would see it like that. I don't know what your social media presence is now, but let's assume lower social media presence in terms of this industry, at least, do it just for yourself, as a record for yourself, as notes for yourself, as just reference, and just showing people that you're progressing. As long as you're progressing, at some point, someone's going to value that. Someone's going to want to pay you for that. You're going to solve something that someone had a problem with, and you're the person that can solve that. And perhaps you can connect with others as well. You'll find your tribe, build an email list, put some blogs out there, get people to give you their email address. Send them something in their inbox once a week, once a month even. But just get as much content out there as possible for your own record and for connecting with others. Does anyone else have any other questions?
Thank you for your time, sir. I want to know what is your inspiration to push through every trial, tribulation, challenge, setback, and disappointments?
That is a really good question. Can I answer with a really cliche quote? It's if you're going through hell, keep going, because otherwise you're just going to stay in hell. And honestly, that's a big part of it. Like I was saying earlier, I don't know who it's by. I think it's actually, it might be Churchill, but he gets a lot of quotes attributed to him. It's like, as Abe Lincoln said, don't believe everything on the internet.
As Abe Lincoln said that too. Nice.
Yep. No, but like seriously, a lot of it is just I enjoy the challenge and I like to find excuses to challenge myself. And then once you're already being challenged, just keep going until you figure it out. And then when life gets too boring, find a new challenge to go for.
But this is coming from someone who has a very, I would say, stoic approach to life and kind of likes pain. This is a guy who runs marathons. You run what, 16 miles every few days, right?
Yeah, I usually do like 16 plus miles every Sunday.
Okay, so once a week.
Yeah.
You go to a boxing gym, you spar. Any other pain?
Honest, I don't know if people know this, but it is extremely relaxing to finish your workday and then go punch people in the face. And they like it.
Do you like getting punched in the face too?
Honestly, you stop noticing after a while.
Oh man. Yeah, the struggle, embracing the struggle is actually really good. And embracing the struggle, both the physical drain on your body that's going to happen, but also the mental strain. And really enjoying that and embracing that struggle, I think is good, which is, I think, the crux of that whole, if you find yourself in hell, keep going. Thank you so much for the question. We have time for just a couple more. Any other questions out there? Yes.
Chicken sexers, right? That's the name for the job, which is like the weirdest name for a job that ever existed. Anyway, so my question is about, we're in a tech world where frequently it's like, if you are not growing exponentially, you are dying, right? Like, and so like, I really appreciate that your book is about senior engineer and not like principal engineer or distinguished engineer, but I find it hard for a lot of people. Like, we're surrounded by an industry which is telling us you have to be going up like a rocket all the time. Like, how do you see people have success in subverting that instinct and that sort of like that rush of, oh, everybody's passing me, I have to be growing in the same way too,
That is a good one. So one thing is that there are different ways to grow as a senior engineer. You don't have to increase in titles, but someone who's a senior engineer at a 10-person startup is probably at a very different level than somebody who is a senior engineer at, I don't know, Google, because that's the easiest example to give. So you can get more interesting challenges or better challenges by changing what kind of company you work at. So you don't have to personally be growing exponentially. You can just go on a tide that's lifting all boats and be one of the boats and just kind of chill there and do interesting stuff. Man, I'm actually a really bad person to ask this, because just the other day I was saying on Twitter, somebody was like, well, you don't have to keep growing and challenging yourself and doing all that stuff. And I was like, I think you're underestimating the level of my ambition. So maybe I'm not the best person here to ask that, but I think there is a pleasure that you can get in just maintaining. And if that's what you enjoy, and if, I have a lot of friends who have very fulfilling lives, and they're like, hey, if I live in Portugal and I work for US companies, I can work for 3 days a week and spend the rest of my time surfing, and it's fine. It's great. Like, I'm just enjoying my life. Or I have another friend who realized that he's making enough money for the area he lives in, and now him and his boyfriend have 20 horses and are figuring out how to run a horse breeding business on the side while they spend like a couple hours a day working in tech. So, there's a lot of these options out there. I don't think you can or need to always be growing exponentially. It's just that the industry we're in, at least, that's what the VCs expect of their companies, and then that's what the companies expect of us, and it's kind of a self-reinforcing cycle. And honestly, if you don't want that, San Francisco, or at least tech in the Bay Area, probably is not the best place to be. There's a lot of other places where people are less focused on infinite forever growth and more focused on, hey, we're doing well enough, go have fun.
So I think that does it for the questions. So I have one more question. So you've written a number of books. You've written React and D3, Senior Engineering Mindset, of course. Any others I'm missing?
Serverless Handbook.
Serverless Handbook, that's right.
Yeah, but once upon a time I wrote Why Programmers Work at Night.
That's true. But all of these were self-published, correct? But
Actually, there is one that wasn't self-published. I did a book with packed data visualization in D3.js. This was many years ago now.
Nice. Okay. But I saw you just updated your name in Twitter to Swiz is writing a secret Manning book, or just a Manning book?
It's just a Manning book. It hasn't been announced yet. Yeah, so the book hasn't been announced yet because I am very slow at writing it. But I'm writing a book with Manning about how to rewrite your software while there's people banging down the door to use it. So the idea is that a lot of people in tech are afraid of software rewrites, but I think that software rewrites are actually one of the key tools that you can use to build software for a fast-growing company, or just in general to build software. So the book is basically about how to think about rewriting your code so that you can constantly keep rewriting it, and in that way stay ahead of the curve or something. I'm still working on the marketing material.
And rewrite in greenfield, brownfield, or
all of it.
All of the above.
Yeah, it's kind of half philosophy about how to structure your code so you don't have to ever say, oh my God, this is terrible, we need to throw it all out, but still be able to constantly adapt to market pressures and keep rewriting it piece by piece.
So with a focus on modernization of the code. Yep. Okay, got it. I may have a workshop for you, actually.
The Adobe Figma story is a really good example of what I'm talking about. Adobe is a 40-year-old titan of design software that just bought Figma for $20 billion, which is a 5-year-old company. Why wasn't Adobe able to build what Figma built, despite their many, many billions of resources, tens of thousands of people working on it, and decades of experience in the exact problem that Figma went and solved? A big part of it is because some of it was their culture was calcified. They were thinking about the wrong problems, but it's also one of the key features of Figma is multiplayer mode, where multiple people can edit the same file together. Adding that to something that you've been building on the desktop for the last 20 years is nearly impossible. So if if they had a better culture of continuously adapting, rewriting, fixing their software as they went, they maybe wouldn't need to buy a competitor to solve the problem.
And these were also very new technologies that they leveraged. I think they leveraged CRDTs, right?
Yep.
Yeah. So yeah, these are very new technologies that they
yeah, but you know,
they implement.
5 years to go to get 20 billion exit, not bad.
No, not bad at all.
Yeah.
Swiss, thank you so much. It's been an absolute pleasure. Thank you for sharing your knowledge here. Let's give it up for Swiss Della once more. I want to thank you all for coming out again. It's really great to see such a great turnout for the React meetup coming back, and the Jamstack meetup as well coming back after more than 2 years. Thanks so much again to Checker and the team. Can we have a hand for Checker, please? Phenomenal. Is it okay if we stick around for a little bit? Hang out? All right, so we got till 9 p.m. So 20 minutes, we can hang out a bit. All right, see y'all.